We did our project on Chapter 7, which is random variables.
The definition of a random variable is a variable whose value is a numerical outcome of a random phenomenon. When using random variables, you always use capital letters, and it can be represented by P of, in parentheses, capital X, or the probability of an event X.
One type of random variable is a discrete random variable. For a random variable to be discrete, there must be a countable number of possible outcomes. Discrete random variables can be shown in a table, otherwise known as a probability distribution, where the possible values of x are on the top row and the probabilities of each of these events are on the bottom row. The probabilities on the bottom row will always add up to 1.
An example problem for discrete random variables is that MHS announces the distributions for the number of sports each senior plays. 18% play none, 39% play 1, 28% play 2, and 15% play 3. Below is the probability distribution for the scenario. As you can see, the probability values add up to 1, or 100%.
Another type of random variable is a continuous random variable, which means that it takes on all the values in an interval of numbers. The probability distribution for a continuous random variable is a density curve, and remember that the area underneath a density curve is 1.
Also, for continuous random variables, only intervals of outcomes are assigned a probability, for example, between 3 and 6. However, probability of x, a single number, is always 0. So the probability that x equals 1 is 0. There's also no difference between greater than and greater than or equal to, and less than or less than and equal to.
These are the 6 formulas to memorize for combining normal random variables. There are 3 for combining means and 3 for combining standard deviations. Note that adding and subtracting standard deviations uses the same formula. Also, note that when calculating standard deviations, we always work with variance first.
Now we have a quick example problem for combining random variables. So the situation is, before your friend can come pick you up, you have to do the laundry and clean your room. The time it takes you to do the laundry is normally distributed with a mean of 5 minutes and a standard deviation of 1.4. The time it takes you to clean your room is normally distributed with a mean of 14 minutes and a standard deviation of 2 minutes.
Since the problem states that the time to do laundry is normally distributed, you can place it on a normal curve. As stated, the mean is 5 and the standard deviation is 1.4.
This graph shows the normal curve of cleaning your room with a mean of 14 and a standard deviation of 2.
For this problem, your friend is coming to pick you up in 20 minutes. What is the probability that they will have to wait? AKA, what is the probability that doing your chores will take you longer than 20 minutes? The definitions of the variables are on the left of this slide. Note that t is the total amount of time that your chores will take you. First, we need to combine the means. We used the formula on one of the previous slides to see that the combined mean is 19. Next, we have to find the combined standard deviation for the two. We also used the formula from the previous slide to find that the combined standard deviation was 2.44. We put both of these on a new normal curve.
For this problem, you're going to use the normal CDF function on your calculator and start at 20 and go up to infinity, since this is the region that you're trying to calculate for. You use 19 as your mean and 2.44 as your standard deviation. From this, you come out with a 34.10% chance that your friend will have to wait.